In this video, we are going to be doing some select problems on pages 7 through 10 in your quarter 2 booklet. So we're going to skip around a little bit. This is just to help give you some additional practice on the slope and the slope-intercept lesson that you did previously. All right, so if we look at this first one here, that we're going to look at towards the bottom of the page, and it tells me that x is equal to 5. So hopefully by now in my mind I have that vertical lines have undefined slope because all the x values are the same. So what that tells me, if I go over to where x is equal to 5 right here, that's the point 5, 0. But if I wanted to plot a lot of points that had 5 as the x coordinate, here would be 5, 1, and here would be 5, 2, and 5, 3, and 5, negative 1, and 5, negative 2. So this x equals 5 is a line that includes every ordered pair that has an x coordinate of 5, and so that would be the blue line. So our first example is a vertical line. Our second one here is y equals negative 1/2 x plus 9. So I would go to the y-intercept there, which is at the point 0, 9, right there. And then my slope is negative 1/2. And so I'm going to think of my slope as negative 1 over 2. So I'm going to go down 1 and to the right 2. And so when I go down 1 and to the right 2, and you keep that pattern up. That's a consistent pattern all the way through. And then use a straight edge to connect those points. On the iPad here with this Apple Pencil, it's a little tricky for me to do that, but I'll do it as close as I possibly can. On this next one here, 8x plus 2y equals negative 16. The first thing we need to do is to take this equation and to get it into slope-intercept form. So basically, I'm using that solve for y that we practiced last lesson. So I'm going to take this 8x over to the other side, becomes negative, drop down that negative 16, and then divide by 2. And so now I'm going to be graphing y is equal to negative 4x minus 8. So I take this equation that was given to me in what we will learn that is called standard form, and I move it first into slope-intercept form. So I now know that I'm going to start at the y-intercept, which is at 0, negative 8, right here on the y-axis. And my slope is going to be a negative 4. Now, that is really over 1. And so I might look at that as down 4, right 1. But if you look at my y-intercept, I can't really go down 4. I run out of graph. So I have to reverse this and know that the same movement would be to go up 4 and to the left 1. And then to repeat that. And I could still see that the line that I'm going to be generating is one that's going to have a negative slope. All right, let's go ahead and turn to the next page. Let me zoom this out a little bit here. Here we go. And ask us in this first problem for the rate of change. Now you can do this a couple of different ways. You might just notice that this is my x value and this is my y value. And if you look at this is going up by 6 as this goes up by 1. And so my change in y over my change in x would be 6 over 1, which for this particular problem would mean an increase of 6 meters per minute. (6 meters per minute. You could also, if you wanted to, take and write down two ordered pairs, 1, 6 and 2, 12, and actually do the slope formula. Get you the same answer. Rate of change we look at is just either an increase or decrease, and then of what? In this particular problem, it was of meters per minute. Okay. If we look at this one here, you can see that from 30,000 to 29,000, that is a decrease of 1,000. And we went from 0 to 2 minutes, and that's 2 minutes. If it's decreasing 1,000 every 2 minutes, that means it's decreasing 500 every 1 minute. And so think about an airplane descending, it's going down. And so therefore, that is a decrease of the elevation feet per minute. Okay. If we look at the next one here, notice that it asks us to find the slope. And that if we look at this first one here, I know it's increasing, so I know it's going to be positive slope. And so I'm going to select 2 points. I'm going to select this point here and this point here. And I'm going to count and say that I'm going to count up 1, 2, 3. That's a positive 3. And then I'm going to count to the right 1, 2, 3, 4, and that's a positive 4. So remember, we take the rise over the run, and so our slope, the rise is a positive 3, the run is a positive 4, and that is our slope. If we take a look at the next one, we can see that this is decreasing, it's going downhill, and so I know that when I'm done, my slope should be negative. And so if I take this point here and this point here, that I'm going to go down 1, 2, 3, 4, 5. So that is going to be a negative 5 move. And then I'm going to go to the right 2. To the right 2 is a positive 2 move. So there's my negative 5. That's my rise. Downhill of 5, and then my run of 2, and that is my slope. If we look at the next set of problems, it asks us to find the slope. And so when we're looking for the slope here, we are given 2 points, and so we're thinking about using slope is equal to the change in the y values over the change in the x values. Now, I always want to look for shortcuts. If I can cut out some work here, I'm going to do it. And I notice that this one here has a shortcut. And I notice it because I see that there's a 2 in the y value here and a 2 in the y value there. And if I know this, and what that tells me is that horizontal lines, describes what they look like, have a slope of 0, tells me the slope, because all of the y coordinates are equal, tells me that looking at this particular set of ordered pairs, if both of these y values are 2, every point on this horizontal line would have a y value of 2, and therefore the slope would have to equal 0. So there is a shortcut for us if we see that connection. Now the great thing is that when you're still learning here, if you don't see the connection and you start to just do the slope formula and you take your y2 minus your y1, you're going to very quickly see that there's a 0 in the numerator. And when we do x2 minus x1, we know that 0 divided by anything will give us a 0. I also notice that if I look over here in number 3, I see that my x values are the same. And if I know that vertical lines have undefined slope and all the x values are the same, then I immediately know in this problem that the slope is undefined. Now, if I didn't catch that, I could start to do my slope and say my y2 minus my y1 divided by my x2 minus a negative 2 turns into plus 2. I get a 0 in the denominator. Remember that anytime that 0 is under in the fraction, that the slope is undefined. So think under, undefined. And so we have to really make sure that we know the difference between this here, which gives us an equal 0, and this here, which tells us undefined. And it's whether or not we are dividing by 0 or if 0 is being divided by another number. So out of those 3 slope problems, 2 of them had shortcuts. If you notice where those coordinates were the same, you can immediately go straight to that answer. Now, this number 1 here doesn't have a shortcut for us. It has 2 points. I have a 2 and a 3 for the x and a 1 and a 4 for the y. So no repeating values there. So I'm going to have to take and actually figure out my slope for this by using the slope formula. So I'm going to take my y2 minus my y1 over my x2 minus my x1. 4 minus 1 gives me 3. 3 minus 2 gives me 1. My slope is 3.